All right, welcome to Unit 5 on circular motion and gravitation, lesson number 2 on horizontal circles. And in this second example, we are talking about a car trying to turn a corner. All right, and with that said, we're going to jump right into this question. There's not a lot of extra information needed to solve this. So, example 2. It asks us, what is the maximum speed that a car can round a corner of radius 100 meters if the coefficient of static friction is 0.50? Okay, so I've already sketched out our little diagram here. It starts out having this diagram drawn in your book minus the forces listed on here. So in the upward and downward direction, we have, force of gravity is going to be pulling this car down into the earth. Force normal is preventing that object from sinking into the earth. Pulling towards the center, we have some centripetal force. So I just wrote centripetal acceleration. The force is going to be the mass times that. And then preventing this object from, getting just sucked straight to the center, we have the force of friction. All right, and that's what's going to be keeping us stuck to the road, essentially. So what do we have going on then? We have a few things that need to be addressed. Essentially, what we're going to want to do is we're going to want to equate these two forces. We're going to say that force friction is going to be equal to this centripetal force. And to find force of friction, I should write this down, force of friction is equal to mu times force normal. That's something we've said before. And we know that force normal in this case, or we haven't proved it yet, but we will, is going to equal the force of gravity. All right, so we're going to be doing some fairly heavy formula manipulation, probably some of the heaviest we've done. It's a little bit of an intricate question. And you might want to, if you're struggling with this, watch this video through a couple times. I'm going to try to explain it as clearly as possible. Let's see how much success I have with that. Okay. I'm going to start with the vertical axis because I know where we're going with this. If you were solving this for yourself, you may want to solve maybe a little bit more from the end, from the back side. But I'm going to start at the beginning. So we have the vertical axis. Okay. And here in the y direction, I'm going to say that F net in the y direction is equal to 0. Right? Because this thing's not flying away and it's not sinking into the ground. And I'm also going to say that F net y is equal to the sum of all the forces in the y direction. So upwards here we have force normal, downwards, so I'm putting a negative sign, so minus force of gravity. If we want to combine these two formulas, we can substitute the 0 for F net and say that 0 is equal to the normal force minus force of gravity. If we want to rearrange this further, we can show the proof that force of gravity is equal to normal force. I think this step, we should be at a stage where we can do this largely in our heads. Okay. Well, next on the agenda, things are getting a little bit different here. We're going to talk about, so technically I'm jumping into the horizontal force realm right now, but we're going to keep it here for a second. Maybe I'll make the color a little bit different. We're into magenta. So we're going to say force of friction. We know force of friction is equal to mu times force normal. But force normal is equal to force gravity here. So we can substitute in force gravity for force normal. So in this case, we can say that force of friction is equal to mu times force gravity. And then we're going to expand out force gravity and say force friction is equal to mu times mass times acceleration due to gravity. Now we still don't have the mass, but bear with me, this is going to be handy later. And again, this is where the rewatch might come in and be really handy. All right, let's go horizontal axis. Horizontal axis. Perfect. All right, on the horizontal side of things, let's balance some forces out here. And we can say that F net is equal to mass times acceleration. We can also say that force of friction is equal to this centripetal force. Okay, so we can say force of friction is equal to force centripetal. This is the mass times the centripetal force. And we can say that force friction is equal to, MAC. All right. Let's substitute in this new value here, this force friction value. Let's see some magic begin to happen here. We're going to put this in for that. And so we're going to say mu times mass times gravity is equal to mass times centripetal acceleration. Well, you'll see that we have a mass on either side. We can divide mass out of both sides. So we're going to cancel this mass term here. And remember, when you're canceling, the thing you're canceling out has to be in every single term. I see people all the time canceling like a mass out when it's in like 3 out of 4 terms. Doesn't work. If it's only in 3 out of 4, can't cancel it. Okay, anyways, we have our new situation here, and we have mu times g. So something that we have and we have is equal to centripetal acceleration. Essentially what we can do now is we can solve for AC. But let's take this a little bit further while we're manipulating formulas, because why not? We could solve numerically, but I kind of like the roll that we're on. I am going to change the color up for this next step, and we can go dark green. Okay, so AC, we are looking for the velocity. So let's expand AC out into our velocity formula. We worked with period formula in example 1. Here comes the velocity formula. So we know that AC is equal to v squared over r. All right, well, let's sub this v squared over r in for AC, and we can get mu times g is equal to v squared over r. And guess what? It gives us radius, it gives us mu, and we know g. We can solve for the velocity. So we can say that velocity is equal to the square root of mu times g times r. All right, because we multiply this up, square root it, and we should be almost at our answer and say that v is equal to the square root of 0.5 times 9.81 times our radius of 100 meters. Okay, and it gives us a final velocity of 22 meters per second. And that's all there is to it. I say that so nonchalantly. There's a lot to it, as you can see. A lot of formula manipulation. But with some practice, this stuff should come fairly easily for you. You'll start to notice patterns. You'll start to see things equaling one another. the recognition will be much better. So keep practicing and good luck.